Hello, this is the video on direct variation. We are going to be talking about direct and inverse variation kind of side by side so you can kind of see the difference between the two. So make sure that you have one of these graphic organizers and you can take notes right on it. Direct variation we talked about last year a little when we were talking about linear functions. Inverse variation, this is the first time you're seeing it because it's a rational function. Okay, so for direct variation, it is always in the form y equals kx, where k is a number. So example, something like y equals 3x. Okay? And what that is kind of saying is that we're taking x, we're multiplying by 3, and that gives us our output. Okay? K we sometimes either call the constant of variation or constant of proportionality. You may see either one used. Okay? So direct variation, looking from the rule, is linear. Okay? An inverse variation is when they're kind of opposite. So it is a rational function. So it looks like y equals k over x, where k is a number. So y equals 3 over x. Okay? And the difference kind of between a direct variation and an inverse variation is that in a direct variation, as x increases, so does y. Or as x decreases, so does y. In an inverse variation here, you can kind of see because x is in the denominator, as x increases, y decreases. Or as x decreases, y increases. Okay, so this is linear because they're both doing the same thing. This is going to be a rational function because they're doing the opposite, right? One of them is winning out over the other. Again, in this one, just like over here, k is still called the constant of variation or the constant of proportionality. Okay, so let's talk about the graphs of both of these. The graph of a direct variation is linear, right? It has the same slope anywhere along the line, okay? And another important fact is that it goes through 0, 0. Okay, so it goes through 0, 0, kind of increases, right? That's kind of what makes it proportional. For inverse variation, it has a very interesting graph. Because, like we talked about at the beginning of this unit, with rational functions, at some point here, right, y is winning out, okay? But then at some point, x starts to win out again. And we start to see sort of this strained sort of half and half behavior where one is winning for a while and the other one wins for a while. So this is the graph of an inverse variation. Another thing you might see most of the time with real-world examples is starting really high and going really low. So kind of almost like the opposite of what you see here. It's just really x sort of loses in the beginning and then y starts to win out. Okay? All right, so let's look at the table. Both of these tables sort of have patterns that are kind of in line with their equations, right? For a direct variation, so y equals kx. For a direct variation, if you take y and you divide it by x, you should get the same number every time. So, excluding 0 of 0, of course, because that's just where we start. 6 divided by 1 would give us 6. 12 divided by 2 would give us 6. 18 divided by 3 would give us 6. Okay, and that's because of this relationship. It's a multiplicative relationship, so we're kind of having a scalar every time. That's a direct variation. Now an inverse variation, because it's y equals k over x, when you multiply x times y, you should get the same thing every time. So here, 1 times 30 gives me 30. 3 times 10 gives me 30. 4 times 7.5 gives me 30. 10 times 3 gives me 30. 0.5 times 60 gives me 30. Okay? So basically, every time you multiply the x and the y, you should get the same number. That's what makes it a inverse variation. Okay? And if you are curious about what k is in both of these circumstances, oh look, k in this circumstance is going to be 6. K in this circumstance is going to be 30. Something kind of interesting there. All right, so the kind of problems you're going to see with direct and inverse variation are these, or you may see them in an applied context, but it's really the same idea. So let's go ahead and look at this problem. It says if x varies directly as y and x equals 27 when y equals 6, find x when y equals 2. So let's break this down. Let's start with this. X varies directly as y. That means that we have the format y equals kx. We don't know what k is yet, okay, but we know that it's going to be in this form. Then they give us this clue. X equals 27 when y equals 6. That can help us find k. So what I can do is I can plug in 27 and x where I see x and y. So y would be 6, x would be 27. Now, if you notice, I can figure out what k was so that when I multiply it by 27, it gave me 6. So I'm going to divide both sides by 27 here to find that. Grab a calculator. Now we can do k in two forms. We can leave it in fraction form. Both of these have a factor of 3. So I could say that was 2 over 9. Or if I wanted to put that in a calculator, I could say k was equal to 0.22. Because this is our rational functions unit, let's go ahead and leave it as a fraction. So really, our equation is y equals 2/9 x. Notice that I took out the 6 and 27 because that's really only one point in my table, and this is the equation for the whole table, right? This is my function equation. This is my rule. The next part of the question asks us to find x when y is 2. Okay, we're trying to find x, but we do know that y is 2, so let's go ahead and plug in 2. And then we can solve for x. How do I get rid of multiplying by 2/9? I divide by 2/9. And here I have sort of fraction division. I have 2 divided by, let me write it this way for you, 2/9 equals x. Okay, using fraction rules, that means I just copy the first one, flip, and switch that to multiplication. And actually, I notice that I have a 2 in the numerator and a 2 in the denominator here, so I can cancel those out, and that gives me 9 equals x. So what that means is when y is equal to 2, what I put in was x equals 9. Okay? Questions. There we go. Okay. Let's check out this one. This one says if y varies inversely as x and y equals 23 when x equals 8, find y when x equals 4. So here's the first part we want to look at. Y varies inversely with x. That means we're going to have y equals kx, where k is a number. Right now, we don't know what k is, but we can find it. Okay? Let's do this next part. Y equals 23 when x is equal to 8. So, y is 23, x is 8. Okay, now we can kind of find what did I divide by 8 to get 23. So I can multiply both sides by 8. And that gives me 184. So what that tells me is that in this equation, k is 184. So let's go ahead and replace that, taking out our x and y, because remember that's only one point. This is our function rule. This was at a certain point. Okay? Now let's look at this last point. Find y when x was 4. Okay, so we're trying to find y, that stays y, and we know x is 4. Ooh, this is actually going to be really easy to solve. If I take 184 and divide it by 4, I get 46. So when I put 4 into this function, I get out 46. Okay. Alrighty, go ahead and label this into your notebook, and there's a practice worksheet for you to try. If you have questions, please let me know.